So welcome. I guess that's the only room logistic we have. So we got some interesting trends going on in merger acquisition, regulation, and there's a boom going on in oil and gas. So part of the reason why Michael's here is to talk to us about how Spotfire is going to enable that and help us handle, I guess, those conditions. So Michael, I've known for about a decade. I think it's at least maybe 12 years.
Probably at least 2010 something.
So how many, Michael, how many years have you been with Spotfire?
I think 12.
12 years, okay. Yeah, so I think I've pretty much known you right from the very beginning. So this event is a result of the event that was held in Houston in May. So there was a number of oil and gas companies that got together in Houston. It used to be called the Houston Energy Forum. Anybody gone to the Houston Energy Forum in the past? Ooh, there's a couple. Yeah, of course, Michael. And it was a great event. So there's about 110 people at the Houston Energy Forum and some great speakers. Chesapeake was there, ExxonMobil was there. So it was a really good event. So we felt that if Michael was willing to come out to Calgary, well, why not have Michael in Calgary? Has anybody seen Michael speak before? How many people have seen Michael speak before in the room? One person. Wow. Hey, yes. So Michael does have his PhD, and he has, he's the driving force behind Spotfire. So there has been some changes with Spotfire. Spotfire, it's its own business unit now. It's no longer part of TIBCO. So that there's the good and the bad about that. Well, I guess the mainly good though, right? And Michael, you're probably going to talk about this. But because Spotfire, it's its own business unit now, what we're seeing is there's a lot of investment from Cloud Software Group going into Spotfire. So it's a brand new, I'll call it, it's almost like a resurrection in essence, right? And energy being one of the top verticals for Spotfire for sure. But going back to when I was in Texas in May, I went to Michael's event, and I also went to Hart Energy put on a big event with C-level executives that basically came to the stage, and those were the three things they talked about. They talked about merger acquisition. I think there's a few that have gone on, some massive ones. Who's buying Marathon, Michael? Do you remember? Conoco's buying Marathon. Hess is being acquired. ExxonMobil's buying more. But because of the Biden government, there's a lot of regulation. So a lot of those deals are under scrutiny more so than ever before. And the reason why I tell you that is if there's any kind of merger acquisitions that are going to happen here in Canada, it's going to be important to have the data to get through those regulation hoops as quickly as possible. But then they started using the boom word. So when's the last time we heard oil and gas boom in Calgary? A long time ago. So anyway, there's a lot of positioning going on. So we're going to talk a little bit about today. Our topic today is going to be visual data science and AI using Spotfire. And there's a number of different things that Michael's going to touch on. So let me take you through the agenda. So the first presentation that we have is Michael. And then Ryan's going to come up and talk a little bit about what we're doing here at Cadeon to help our customers that are using Spotfire. Mainly training. But we also have been working on this thing called an oil and gas toolkit, which is a standard set of visualizations for oil and gas that we believe that oil and gas companies should have to start with. So that's a little bit of a, what would we want to call it, Ryan? Accelerator? Yeah. So, and then we've got a customer panel. We've got two volunteers that have been gracious enough to come up and talk to you a little bit from a customer standpoint and their experience with Spotfire. And then we're going to close the session out today with Michael's going to update you. We left the best for last, maybe, which is what's the future look like for Spotfire? What's on the roadmap? So that's our agenda. Any questions before we get started? I'll start with a question. How many people know why Spotfire is called Spotfire? And you can't answer. Anybody know why Spotfire is called Spotfire? Michael, do you want to answer that question?
I'm curious as to what you think it is. When we started back in the early 2000s, we just came up with the word, but since then it's been reinterpreted in many ways.
So the interpretation that I know is because it was to spot the fire. It was to visualize the data.
That was what I started calling it when I joined, but It wasn't the original.
Oh, okay. So what was the original?
Someone just came up with it. It was like the circles were like the Spitfire of the car.
Ah. So all those people that have mispronounced it Spitfire they were sort of right?
Yeah. We borrowed that.
Okay. Awesome. All right. Well, that's it for me for now. And you guys will hear more from me later, but I'll turn it over to Michael. So let's give Michael O'Connell a big Calgary welcome.
So I'm going to go through the new positioning, talk about AI everywhere and how we're using that. We actually have a company here in Calgary who's a very early adopter of that. I couldn't make it today, but Carbon Alpha, very early adopter of the Spotfire Copilot. Get into a little bit of energy sector action and wrap up with a community summary. So as Phil mentioned, big news is that we've separated from TIBCO. So now we're back as Spotfire. We've got our new logo, new website, new community site. New money, as Phil mentioned, from the Cloud Software Group. We are a business unit inside of the Cloud Software Group, but we're no longer part of TIBCO. TIBCO acquired us about 10 years ago, and so it was a lot of celebration when we spun back out of TIBCO about 6 months ago. So we're thrilled about that, and we're launching and rebranding ourselves as Visual Data Science. And really that means visuals first, data science where needed. I'm going to talk about some of the new visualizations with gun barrel diagrams, looking at, say, formation tops, where you're drilling, how to well space. So we're really getting back to our roots of visual first data science inside of Spotfire. There's the gun barrel diagram, the formation tops, looking at the well placement, that kind of thing. Being able to do very precise measurements, so measuring different directions and distances in different ways to understand where you're going to put wells, collaborating with our customers a lot. So this was some work that we did with Exxon, as Phil mentioned, who presented at our Energy Forum in Houston. But yeah, visualizing the data first and then bringing on data science throughout the process. And the reason we did that, kind of like, I was at my ophthalmologist a few months ago, and he was looking at the retina, and a lot of you see something, goes through the optic nerve, the retina captures a picture of it, goes through the optic nerve, goes to the brain. All that happens in a very short amount of time. And so we believe we're the software that allows you to visualize data first. And that's immediate, right? 13 milliseconds. You don't need to read about it. You just recognize it immediately. And it turns out the human brain processes entire images that the eye sees for as little as 13 milliseconds. And we just really believe in that. We think if you bring the data into an interactive, visual first approach and then process it with some extra help from data science algorithms, that's the way to analyze data. And we've got a lot of fans. In fact, the CEO of Cloud Software Group, when I first met him, he came from Broadcom, and he was like, so you're the leader of this Spotfire cult. Because everybody thinks it's a cult, and it sort of is. It's like I go to different cities, and the people who are just real fans of Spotfire show up, and they don't want to use anything else except Spotfire. Now, there's certain other people at the executive golf course level who want to change that, but I'm happy to talk about that at some point with you guys too. But that's the genesis of it, and so if you can visualize the data and then bring in algorithms to help you understand the patterns, we believe that's the recipe for success, especially in energy sector exploration, drilling, completions, production, HSE, and so on. Time and again, we've seen how Spotfire can help drive value in those sorts of areas, and we've been building our product to do that. And the difference, let's talk about these golf course people, is that the user here is the domain expert, the geologist, the field engineer, the scientist. You can connect to multiple data sources, multiple layers. There's data virtualization inside the product. You explore the data, wrangle the data in line with the visuals. So you're visualizing, but you're also wrangling at the same time. You can integrate models, and then creating, Save As To library creates an interactive application that literally runs businesses around the world with thousands of people clicking around in a web browser. And that is very, very different to sales analysts creating a report and pushing out a dashboard. Very, very different to that. I know people like to compare us to tools like that, but it's kind of chalk and cheese, and if anybody wants to talk to me about that, happy to do so. And also, it's very different to a data science platform. Those sorts of pipeline tools where you get a data set and you split it up into a train, test, evaluate, and you kind of figure out the best parameters and you do all these distribution checks and all of that, and you end up with a model. That's different too, because we use models. You can build them if you like in Spotfire, but we use them to supplement a visual. So we put out a Spotfire application as opposed to a function, as opposed to a report. Now you can do all of that in Spotfire. I've got some other presentations about people from Shell showing how Spotfire is a superset of those other things, but mainly just hands-on visualizing the data and bringing data science in is our sweet spot. And we've been at this AI stuff for a long, long time. I know there's a lot of interest in that right now, and I'm going to talk about it. But when we first were invented back in the 90s, we started off, we brought in the Geoffrey Moore, Crossing the Chasm of Fame. Who's read that book, Crossing the Chasm by Geoffrey Moore? Not too many. Okay, great book. He drove a lot of software companies in the Valley. By focusing on a certain area to get some business. And so we focused on pharmaceutical R&D at the time. The human genome revolution was out there. People were trying to understand genes, and the data couldn't fit inside of Excel, just like the data can't fit inside of that other product that I won't mention. But we started there, and then we spread across to energy, spread across to manufacturing. Anywhere there was big data that you wanted to visualize, that became our specialty. And then we got acquired by TIBCO 2007, and we kind of lost our way a little bit. We kind of got spread out across all of TIBCO's customers, became sort of a viz tool instead of what we started as a visual data science tool. But thankfully, along the way, we acquired things like S+, GeoAnalytics, Statistica, Streambase, and we started investing in AI back in 2018 when we first put the recommendations engine inside of Spotfire. And now the market's all about AI, so the market has kind of gradually come to us versus us chasing a market like other products. So energy customers, we really have 20 of the top 20. My lawyers told me not to do that because then people would know exactly who our customers were, so I had to put 19 in there. But we're used by every energy customer on the planet for upstream exploration, production, some midstream, downstream. More than 100,000 Spotfire users in the energy sector. Got a lot of partners here. Probably should have had Cadeon up there, I suppose, but this is your partners who actually create applications and so on with Spotfire inside, like Schlumberger's Delphi product, S&P Global, Halliburton. These guys all sell products into the energy sector that really use Spotfire inside of them. And then, like I'm going to talk about today, the idea of having accelerators. So visualization mods, like the well spacing gun barrel I was just showing a bit ago, data science functions, and then accelerators to help you get started on that journey. And under the hood of this is our virtualization software that allows you to federate multiple data sources to feed up views to Spotfire to analyze them, whether that's well data or financial data. And so if you look at across the energy sector, all the use cases we've been used for over the years, all the way from exploration, appraisal, field development, where to drill, how to drill, lease management, equipment, monitoring, rate of penetration, drilling, completions, production, surveillance, optimization, forecasting, trading, workforce management, HSE, sustainability, like the whole spectrum here. And these are the areas that we really kind of concentrate on. So let's go through some of those areas with the elements of the Spotfire product and how we differentiate. So starting off with visualizations, and these are some of the visualizations you can get on community.spotfire.com. And this we've been building out these visualizations so that you've got the inbuilt Spotfire palette, but anything you can do in JavaScript, you can reconfigure into a Spotfire visualization that uses all the same things that Spotfire uses internally. So filtering, marking, drill down, drill up, drill sideways, as you can build out various JavaScript components, and we've built out about 60 of these on our community site, community.spotfire.com/files. You can just download them, bring them directly into the canvas, and we're focusing now on adding visualizations in our key markets, especially the energy sector. So this is all available on the community, and one that we launched at our energy forum in Houston that Phil talked about was this idea of looking at well spacing, combined surface and line charts, well logs, well bores. There's the URL for getting to those. Download them, literally one click.
into the flyout panel, 1 click into the analysis. So 2 clicks to get a visualization like that into Spotfire, and then you just wire up your data, and it's all kind of at your fingertips. And so this well spacing one that I keep talking about, there's a combination of looking at the at the well path, and then looking at the space, looking at that in 3 dimensions, and figuring out where you've got a gap. So I guess this is I'm going to look at this particular area on a map. So the map becomes like an interface to where you want to lasso points and see where they lie. And here I can look down the barrel at the wells. I can sort of rotate that around, understand what I'm producing, and get a real view on top of where I've drilled already and opportunities to drill in the future. And you can layer in on top of this, the formation tops, or you can layer into it, zones of porosity or permeability or different geological attributes. Put those on top of that, visualize those, and understand where you might have a bit of an opportunity, say in here or wherever that makes sense with respect to the geoformations of the subsurface. So pretty cool stuff that we did this in collaboration with mainly with Exxon. We had some inputs from others as well, but that's an example of what we're up to at the moment. Now, other types of visualization mods that we've been developing, this one goes across industries, especially in manufacturing. Now, if you want to look at a distribution of a measurement on a product as a function of different lots or batches or whatever the other variable is, being able to visualize that beyond a basic box plot. So the box plot is included in the violin chart, but you can see if there's multimodal types of distribution that you want to understand. See, this one down here is quite different to this one up here, even though the median looks the same. So being able to understand variability, that's a mod that we've been spending quite a bit of time on. And you can control the parameters of the kernel smooth. These are little t-tests that you run between the distributions. How do you want to smooth the kernel, the bandwidth of the kernel, and so on. Understand the sizes, colors, and you've got a lot of control over how you want to analyze variability. So geospatial is obviously a huge thing for us. We acquired this company Maporama about 6-8 years ago. It has very sophisticated visualizations. People kind of do geospatial first in Spotfire, and they occasionally will use Esri at the end to make a pretty picture, but the actual hands-on stuff of most of our energy customers is done in Spotfire. And it's not just for understanding geographic structures. This is some work we did at HSE for an energy company to look at different types of injuries people might get, or look at the halo around wells, or San Francisco Airport, wafer maps for the manufacturing sector, where we get down to literally nanometers of looking at the overlay analysis between layers of a wafer map. So very precise, takes into account curvature of the Earth, supports a lot of different projections, that kind of thing. So we've through that combination of algorithms and visual first, we're able to do like tessellations or hex spin, measure distances, calculate points inside polygons, optimize routes. Very important in the energy sector that you have this multi-layer calculations within and between layers, because you might have your geology on one layer, your wells on another layer, and you want to do calculations within and between those layers, which is kind of impossible in that other tool that I'm not going to mention today. So yeah, map anything, bring in Python or R data functions, drill down to the nanometer. I don't know of another product where you can make an arbitrary marking on a map and do multi-layer calculations to look at contours of production as a function of geology, or understand relationships between different layers of a map. That's really a specialty. There's a Voronoi tessellation that's added on top of that that allows you to kind of cluster up geology samples with respect to location to a well, and look at production as a function of geologic variables, for example. Okay, so that's visualization. I'm going to rapid fire tour here. If anyone's interested or wants to stop, ask me a question or talk later. But moving along to sort of moving from the eye now to the brain, and what have we been doing in this area to do things like prediction, spatial analysis, value clustering, transformation, forecasting, and so on. So the way you deploy these things, also with the visualization mods, in version 10 of Spotfire we added this flyout, and that allows you to bring in say, data functions, Python or R or Statistica, into the FX part of the flyout. So if I were to email you a data function, you would just click it out of your email into here, and then drag it onto the Spotify canvas. Simple as that. So that's the FX part, and there's the viz part here. You can typically, the way we work in my team is we have a Spotify server. When people create a data function, they put it on the server, and when you go into Spotify, you click these little 3 buttons here. You can just go to the server, bring it in, land it on the flyout, drop it into your analysis. Or you can get it from a disk, as I mentioned. So this becomes a really great way of extending Spotify with data science and visualization to solve problems. And everything now runs from this data canvas. It'll run on a marking, as I mentioned. And so that has this very simple way of deploying. So this is the end user experience, but with on the server has this nodes and services architecture. So when you bring in an analysis, it loads up the packages, manages those on the server. That gets transferred to the web player, or automation services can run using whatever packages they need to run. The automation jobs these days, you can stack and chain these things. The management of the packages is simple. And for folks who want to get hands on code, we put all the data function code underneath these data science functions. We've open sourced that onto PyPy. So you can literally go and look at the Python code that's underneath any of these things that we're putting on the community. And if you want to add to it, you're most welcome. And then with the Copilot that I'm going to get into in a moment, we can just generate this Python code and create a data function and put it onto the canvas and run it for you. So if you don't know much about Python, you can generate the code for what you want to do using the Copilot. But both the author experience and the deployment experience for the administration of this is very, very simple. And so these are some of the functions we've been working on over the last year or so. Anomaly detection, these are various neural network analyses, long short-term memory, autoencoder, local outlier factor, clustering, model evaluation, explainability. Time series analysis has been a big focus for us, geospatial, of course, natural language processing, data prep, transformation. You can get all of these on the Spotify community, and like I say, the source code for those is also on GitHub. So to give you an example of how a mod and a data function kind of work together, I'm going to just show you a quick video of looking at wind patterns in Texas. These are weather stations, and these are various wind turbines, and we're going to get a prediction of wind in terms of direction, velocity as a function of time from NOAA weather data stations, and we're going to use that to predict power generation from wind turbines. So here's the data. This average wind speed per ERCOT data, wind speed distribution, wind magnitude by season. This is spring, summer, fall. We've got that coded into the data set. So as I run this, I'm going to start looking at the wind magnitude by season, the wind speed distribution. Now look at individual turbines, individual weather stations. And now I'm going to bring in a function to predict the wind as a function of spatial location and time. So I'm just going to map this geospatial contour plot to the latitude and longitude of the parameters of what's in your data set. Basically do some clicking to map your data to the arguments of the Python code, put in a smoother, and basically run that. And what I get back here is a object that I can now bring into the map. So that comes back as a geometry object. I've just dropped that on the map chart. Behind the scenes, there's a WKB file that gets estimated. And now I kind of have the contour analysis right on the map. I can click through the buttons, what the wind speed and direction is. I can bring in a rows chart. So you saw these are the panel of mods that I've got in this particular analysis. I can now map the rows chart to the data that I have, the NOAA daily weather data. And now I have, as a function of both space and time, I have a rows chart visualization of wind speed and direction to go with this predictive analysis across the weather station data. So I just ran that quick video to show you how you can extend your analysis with a data function, in this case to do a geospatial contour analysis, and with a visualization mod, in this case a rows chart, to look at wind speed and direction with a handful of clicks. So basically you just have to go out and download the various things here, put them into your flyout, and apply it to your data. The only clicking I did was to map my data to the parameters, input parameters of those functions. Okay, so that's a very whirlwind tour of the visualization side and the data science side of Spotfire and how they kind of come together to allow you to solve some fairly sophisticated problems in a handful of clicks. Okay, so over the last year, we've seen a bit of an explosion in AI. So I want to talk a bit about that. Every time I give this presentation, I have to keep updating this number here. So I first gave this presentation, and everyone was amazed that NVIDIA had a $1 trillion market cap. Then it was $2 trillion at the time of the Energy Forum in Houston about a month ago, and now it's $3 trillion. So it's like, this slide is still relevant, but that number keeps changing. And I did have the great pleasure of going to their tech kickoff earlier this year in Santa Clara. Quite the event. But lots of investment coming into this area. Generative AI apps are on fire. The recent release of the Omni GPT has really changed the game a little bit. So now we can put video in, visual in, chat in. We're able to kind of take screenshots of a Spotfire analysis, send it across, and get GPT to interpret that and give us a narrative on it. All kinds of stuff going on with GPT Omni. And then the others, Gemini at Google obviously is really a big player in this space. Some of the other companies are all based in San Francisco. It's kind of an exciting time to be there, actually. And then open source. A lot of our customers are asking us to support open source models in the Copilot, especially manufacturing customers who don't want to be in the cloud. They don't want any data. These manufacturing customers, I just got back from Korea. It's kind of crazy. When I go to Samsung, who's got like 70,000 Spotfire users, we meet in a room outside of the campus. If you go inside the campus, mandatory wiping of your hard drive of your laptop. So that's how security conscious they are. So kind of crazy, but that's why we are exploring these smaller open source models to deploy them inside of a data center versus through a cloud call. So there's so many models out there now that it's difficult to evaluate the state of the art of the models. I looked on Hugging Face last weekend, 650,000 LLMs and SLMs on Hugging Face. Kind of crazy. And so how do you figure out what one to use? Also, we're kind of running out of human-generated data. These models are trained on the entire history of the internet, and so now we're kind of bringing corporate data into that. Multimodality is the exciting area, and that's what we've been basing the Copilot on. Also, the politics and regulatory situation. Like I said, I was just in Asia, Korea, and Taiwan, Japan. Everyone's kind of freaked out that China's going to take over Taiwan, and so there's a lot of investment. Phil mentioned Biden, so there's a huge amount of new fabs coming into the US because everyone's just worried that China's going to take Taiwan. And there's this chip war. I really strongly recommend this book. It was a fascinating read. It's kind of amazing that all the companies mentioned in this, and there's multiple companies have dedicated chapters and different types of chips that are being manufactured. It's like reading about all the Spotfire customers that are in Asia Pacific and in California. It's really kind of a fun read. But we've been started, as I mentioned, since 2018. We launched the Spotfire recommendations engine in early 2019. Here's a quick video of what that does. So you can basically, when you click from the data panel on a particular variable, when you click there, behind the scenes, we've already analyzed all the relationships with that variable, and we show them to you in order of strength. So you can see there's a relationship of miles per gallon highway with engine displacement, or miles per gallon city, or vehicle size. You can click these into your analysis. They're automatically brush linked. When you click more like this, you get different kind of patterns here. So this is looking at miles per gallon versus engine displacement, and you can kind of click around on those sort of data. And if there's structure in the data, we will have found it. So here I'm finding cars with high mile per gallon highway and city. I click on the light bulb. It kind of shows me what's the relationship there, and the main relationship is with engine type. And if you bring that in, you can see that the cars that are marked here are primarily electric. So that is a true data, but the structure, there's so much structure in that data that we're able to quickly get to insights in a few clicks with the recommendations engine. So we're pretty excited about that when we launched that in 2019. And some of the things that you can do is in the energy sector, you might say, which operator has the highest production. You might type that in, and you get back a graph showing that, and you can click that into your analysis. So a lot of work that we did here, and it's been adopted pretty well from surveys we've done and our own cloud environment. About 30% of people have tried recommendations. It is surprising, though, that people don't know where that little light bulb is and don't know that it even exists in the product. And about 10% of visualizations have been created via a recommendation. This is our cloud data, and 23% inside of Business Author. So it's been pretty decently picked up. But enter 2024, enter the Copilot. Now that we have these large language models, how do we make that simpler and have a conversation with Spotfire? So this is a demo one of our data scientists gave in Houston. And these are LAS files associated with different regions, different points on a map chart. And the question was typed into the Copilot saying, read the LAS files, create a data frame, smooth the value of some of the parameters, calculate the VSH, output 2 tables, one tall, skinny, one wide, and use this Python package Lazio. That was the instructions given to the Copilot. And so what happened is the data function got created for this. It automatically landed inside of the data function properties dialog inside Spotfire. Here's the Python code. It's commented. It gave a description of it. It gave a name to the package. It does the smoothing down here. You can look at the Lazio read of the data, the window length of the smooth. It added in the smooth GR calculation, put that back out to a data frame in a pivoted and unpivoted format. Basically, all that code was written and landed inside of the data function construct. So, all you need to do now is to kind of click, into your data. For example, allow a map chart marking to be the input. And basically, run that on your data. Now, when you click OK and run that, what happens inside of Spotfire as we refresh that analysis there, it looks like it worked. Function ran correctly. Now we go over to the canvas, and we can see that the elements of that analysis, the processing, the putting out the data frames, all of the bits that were in the Python code, has automatically landed in the data canvas. So now you can click on those and you can see the long skinny data, you can see the wide data. One of the things that our friends at Schlumberger were most impressed by was the automatic generation of this pipeline from just the words that we created, we typed into the Copilot. So exciting times in the world of data functions. The reason it's so good at that, you train up the entire internet, there's a lot of Python code out there. Right? So you can now address that very quickly. This is probably the most time-saving piece of the Copilot is this data function creation. I'm going to give you a quick example from the manufacturing sector where everybody's worried about yield. And so if I look at yield on the y-axis here versus the lot of the product, I can see where there's the low yield there. I can see that that's related to the position on the wafer of the different chip. There seems to be this pattern around here. If I look at this one, I can see that pattern and how the individual wafer bin maps, this is the electrical test that you do, how they line up. So you can, I'm going to ask the Copilot, can you make me a visual that looks at average yield by x coordinate? So x coordinate in this direction, what's the average yield? Because I can see this sort of pattern. So it now goes into the individual wafer maps versus the stacked wafer maps, and it creates this visual where it shows, you can see that pattern on the edge of lower yield out at the edge there. Okay, but I want to understand that a little bit more because every little percent is millions of dollars in these type of processes. So can you create me a stacked bar chart to look at the count of bins per lot? Now the bin is the classification when you do the electrical test, what is the chip's performance on those electrical tests, and I want to see where's the best performance as a function of layout of the wafer. So I've now created this, Copilot's created a stacked bin chart where this is test number 1 in blue. Looks like pretty good performance, although some of these positions on the wafer have very bad performance on that electrical test. We can see the spread of the electrical tests as a function of the lot and how that is varied across the spatial layout. Okay, so now I can see the electrical test performance. I've got an inkling that there's a pattern of low yield on the edge of the chip. Now Copilot gives you an explanation of this graph to tell you about the different electrical tests and what the results of this chart really mean. Unusual observations, maximum, minimum, function results as a function of the lot and so on. But now I want to kind of look at, do I have the right one in here? Okay, maybe that's it. There's a second version of this video that I meant to put in here that shows a more detailed structure from a data function as to yield as a function of spatial position. But you get the idea. It's both generation of visuals, explanation of visuals, generation of data functions, analysis of that. So what's going on under the hood here is we have the Copilot has been set up to answer questions, classify questions into different intents, and generate charts, generate code. The intents are, generating code, generating charts, interrogating your data in Spotfire, having a custom conversation, how to use Spotfire, for example, how do I color a scatter plot by a third variable or something like that, or general Q&A, potentially on data science type topics. And when you ask a question, the Copilot determines the intent of your question, classifies your question into one of these 6 bins, and then invokes the best language model to answer that question. And so this, calculate this chart showing average yield by x coordinate. It shows yield as a column of the data. It created categories to form the bars of the bar chart. It chooses the aggregation and the visualization type. And you don't have to have a column called yield in your data. It knows figures out what column that is. The previous version of Spotfire recommendations, you had to have the exact column name when you asked that question. But now you can more have a conceptual conversation with the large language model, which is really helpful. Because the large language model, the embeddings break up all of the English language so that if one word is similar to the word you're asking, it'll find that word. The whole idea of embeddings of a large language model is how the English language gets classified so that when you have a conversation, it knows what's what. So tools that, required you to set up a semantic layer of words and an ontology, that's what people were doing a few years ago, they're kind of outdated now because you don't need that. The large language model knows how to have the conversation based on all of the embeddings that it's created through its training set. I won't mention what product I'm referring to there.
So Michael, question for you.
Question, okay.
So what is the genesis for Copilot? You guys jumped on this early, right?
Yes, we jumped on very early, yep.
And I think there's some big...
I think it's funny, when we first started working out of Santa Clara and started meeting the Citrix people, that was the impetus for it, actually. Because Citrix is the largest partner of Microsoft. We just signed a deal where we're spending $1.65 billion with Microsoft over the next 8 years as part of, so Citrix is part of Cloud Software Group, so are we. We've literally got 8 employees of Microsoft, paid by Microsoft, who sit at Cloud Software Group. So when I met those guys, I'm like, what do you guys do? And started telling me all this stuff, and I'm like, okay, so I went to Microsoft Build, I think it was last year. And everyone was talking about this. And Microsoft had done a deal with OpenAI to get GPT inside of Microsoft. They call it the OpenAI service. It's part of the Microsoft Azure cloud. And so I started meeting all these guys, and I'm like, man, we should just create a Copilot for Spotfire. So we did. And we were very fortunate to have these people from Microsoft. There's an experience center in Mountain View. I put my data science team down there. We had these hands-on sessions. We figured out how to call all the Microsoft services for doing the vectorization of the tokens and all of that. So this back-end part here, we started off with Azure, and we put all of our Dr. Spotfire videos, all of our training manuals, all of our support tickets, all of our product documentation. We scraped that and stuck it into Azure blob storage, ADLS type stuff, and then we created this indexer. So we used the Azure Cognitive Search originally to take the tokens, create the tokens and store them in a vector database, so that when you ask your question in Spotfire, we have this orchestrator that you can download from our community site that will take your question, find out what the intent is of your question, and then go get the tokens that we've got in the vector database to help you answer that question, put that out to a large language model. In this case, the Azure OpenAI service was where we started. But now, so we originally had this deployment architecture on Azure. That was where we started, and that was because we had this great relationship with Microsoft. Since then, we've just generalized this architecture to allow whatever, GCP, AWS storage. We've got open source vector databases now that we can use, Milvus, for example, Redis. We've got different LLMs we can use in a cloud environment. We're also putting on-premises LLMs. But the orchestrator is the part that we keep evolving. This is our code base that forms the Spotfire Copilot. So we continue to add to this. We're using the Lang chain and also Langsmith for doing tracking the latency and token usage to optimize the experience here. So yes, we were fortunate to get an early start with Azure services in this architecture, and then we've just evolved it to include third-party and other cloud vendors and also local libraries. And we're very excited with the new features that we added in the last version that allow you to add your own data. So if you've got PDFs or whatever else of your well data and so on, we now have a way for you to upload that on the server and for you to include that as an option when you're asking your question. So that was a big addition. We also, as I mentioned, now have on-prem large language models and small language models. And we've done a lot of work in the latest release on scalability, accuracy, latency improvements, and so on. There's the bit where you can add your data. And James couldn't come today, but we are very excited to have Carbon Alpha as an early adopter of this in Calgary, being part of this journey that we're on. They're doing some real interesting stuff, and they've deployed this out with us, with our help. So if folks are interested in getting an installation of this and so on, you can do it yourself, download it from the community side. It's a free thing. It runs in its own container. There's recipes for standing up the container that we give you on the download, but we're also happy to help you like we've been helping Carbon Alpha. So that's the history of how it feels. Started with Azure and now it's spread out. And this landscape is hugely active. I got this on the weekend, the leaderboard. This is the Omni model here that is really ranked #1. Everybody's using that these days. These are some of the other ones. Gemini, as I mentioned, from Google is a big one. We're now using this for the Copilot. And as I mentioned, there's so many models out there that academia is now contributing on Hugging Face. We've tested a lot of those to run on premises or in different cloud environments. I just made a note here of the number of parameters. Do I have that up here? Anyway, these are all billions of parameters, and that's I never thought I'd see the day that there would be that many parameters in a model, but that's what's going on. One other thing on this topic that I'll mention, in addition to large language models and generative AI, is we've had a big uplift also in our natural language processing toolkit. And this is where we've been able to bring in some of these Hugging Face models and allow you to pre-process your data to figure out what named entities you want to recognize, or do some stop word analysis, figure out how to break down unstructured data. So if you've got a lot of unstructured data, like in an equipment log or wherever there's lots of text that you want to analyze, this is very helpful in that. And so we've got a number of models this is version 1. We just came out with version 2 this last month, where we've brought in these pre-trained SLMs and LLMs, and we figured out how to basically, the embeddings that I talked about, we're now able to bring those into document properties inside of a Spotfire analysis. So that just reduces the latency of calling those models and allows you to understand like well logs or data where there's a lot of unstructured data. You're able to analyze those quickly through the NLP toolkit, which is a Python package, and like I say, we have the code for that out on PyPy, as well as various examples of root cause analysis in log files. Wherever there's lots of text, we can analyze that. So that's kind of hand in hand with the Copilot separate when you've got a lot of text of your own that you want to analyze. Okay, so I've now talked about visuals, data science, a little bit of AI. The other thing we're focused on in the different industries is to understand how to help people get going, whether it's on equipment modeling or root cause analysis, statistical process control, network analysis, pricing, transportation, mining, energy, drilling and completions. We've been creating these starter kits for certain use cases in our industry customers. And as I mentioned, the energy sector, there's a lot of great use cases from exploration, field development, drilling, completions, production in particular. And so we've been creating accelerators that you can go to the community and download. The one on completions is the most recent one we've done in energy sector for looking at real-time data as well as static data as you're completing a well. trading, replay if you've got OSI Pi data, anomaly detection, SPC, a variety of things that we're publishing up to our accelerator site on the community.spotfire.com/files. Will allow you to download any updated data connectors, data functions, visualization mods, and these accelerators, the fast starts for creating applications inside a Copilot, inside a Spotfire, sorry. And so this flow from connection to data function mods, accelerators, I've shown you a little bit of a taste of how the Copilot can help you create these various pieces in the puzzle, which is really quite amazing. So the last part of the talk, I just want to go through some of the use cases that we've been working with customers on in the energy sector. So starting off with reservoir exploration, characterization, field development, where to drill, that sort of thing. And this is I like this one because it's a great example of what we mean by visual data science, right? So this was data set where we had literally more than 100 seismic data variables. So we started off by doing a principal component analysis and got those down to 6 dimensions that explain most of the data. So then this guy who used to be on my team, I used to work closely with, Peter Shaw, some of you might have heard of him. He said, well, why don't we take those 6 dimensions and put them in a self-organizing map? So these are the 6 reduced dimensions of the 100 variables, and we've now arranged that in a self-organizing map. And so you see down in this corner, the values of those is kind of high. Up in this corner, the values are kind of low. Over here, they're sort of moderate. So this self-organizing map is a neural network that lays out a structure in multiple dimensions in an organized way. And so now I can go down to this corner of the data here with these weights on these 6 variables representing the seismic data. I can make a click there and I see structure in the subsurface. I can make a bigger click, I can see more structure in the subsurface. So this gives you a way of reducing these hundreds of seismic columns into a map that allows you to view the subsurface. Pretty cool. And this is kind of what we mean by visual data science. You've got a visual that explains your data, and you've underneath the hood, there's layers of data science that you're using to be able to elucidate that structure. And that's really why I always love Spotfires. Like, you can just visually interact with something, and under the hood, you do a lot of math. And so what's going on there, we use principal components to get the dimensions of the data, transform the data in linear ways in multiple dimensional space, and kind of figure out what's the best dimensions that capture the most variability in the data, and then lay it out as this self-organizing map that preserves the topology of the inputs and allows you to visualize a high-dimensional space with certain weights. And that was the brainchild of Peter. You remember Peter, right? Yeah, so he's a great guy to work with. Geographer initially. So now we can do things like also, say for example, just look at the TOC as a function of distance. Find where the TOC pockets are. This can help you start to zero in on where you might want to do so. So petrophysics, petroleum engineers, people that use Spotfire as domain experts to be able to explore their data like that. I showed you a bit about the well spacing stuff that we've started working on. We're thrilled for you guys to take a look at this and give us any feedback on it. Download it, take a look at it. So this is the kind of where to drill versus how to drill type of problem. And I've shown you that before, the idea of visualizing in between the formation tops where you have your current wells and understanding how best to locate the new one. Okay, so now we've figured out where to drill. What about the how to drill part? So how do we understand trajectory, rate of penetration, bit wear, operations, real-time drilling, completions? A lot of folks are bringing in satellite data to get views on the data from a map and look at where the current drills are. But when you start a new drilling operation, one of the things is making sure you stay on track. So if you've got a planned trajectory here, that's the best path you've designed, and you start drilling, invariably you go off course here. And so we've got a real-time analysis where you can keep data coming off the drill bit and you can kind of course correct. It's kind of like if you go into a party of someone who you don't quite know on the weekend, you sort of end up over here. Well, then you turn on the navigation system and you get the optimal path back to the party, right? And so that's based on some SPE research that was done. This was also an SPE paper that was done by Shell on bit wear. So the wear factor is a function of weight on bit, rate of penetration, RPM, That wear factor you can analyze in Spotfire, do those calculations and understand your aggressiveness versus bit wear. You don't want to end up with a broken up bit, and you want to pick the right bit for the right problem. Some work that we did with Hess that was presented at the Energy Forum on predicting the seal. So the seal is when you have a jump in overpressure as you go down. So cluster depth versus overpressure, sometimes you get these little jumps. That is indicative of a seal that leads into a bunch of hydrocarbon below that. You want to be able to predict that. So we've got this new well log visualization mod. You can see here, the green is the hydrocarbon, the blue is the water. You can see, right here is a value that you're very interested in because it's right above where the hydrocarbon is. So with this well log visualization, you can look at that, take a slice across there. What are the factors that predict that? And how is that predicted typically as a function of overpressure, where the pressure jumps at a certain state right before the hydrocarbon. And so be able to understand your data that you've already drilled and figure out where the hydrocarbon is, really increases the probability of well success. Predicting hydrocarbons at certain pressure ranges. Can also help you not have to buy a whole bunch of more seismic data if you can make good predictions on what you got. And also just improves non-productive time. So Graham from Hess has done some amazing work here, and it's pretty cool that what they've done in Guyana. Like every drilling operation they've done there has been successful. It's a major new find. And the other thing is when you've got you've drilled a well. And you've got the certain parameter associated with that, and you want to find out where to drill the next well, well, then we can target parameters. This is an analysis that was originally done for time series. It's called dynamic time warping, where you match one with another sequence of data. So the profile might be similar, but the actual data is a little bit different. So you can match the best in the past to the current one and figure out that time to hydrocarbon using the wells on the closest score. So this well log mod that we've launched allows you to understand an optimized rate of penetration, predict the timing of when you get to the top of the reservoir, evaluate a rig's performance, and kind of go across. This is there's like I think 28 variables on this plot, right? So this is depth on the y-axis. These are the various seismic attributes or porosity, permeability, gamma ray type things. And you can see those different columns of data that have been visualized, and we can basically take a slice out of here, the area of interest, and bring that data into Spotfire, put a random forest model on it, and predict when you get to the top there from the other seismic variables. Pretty cool. Okay, actually there's a video there. Let me run that again. Yeah, so here's that. I didn't realize I had a video in there. So you can make a horizontal slice across these columns of data and use that as a data set to do your prediction. So I think we're going to grab a little slice down here a little bit below that. Understand those 5 or 6 variables there. Go across here and understand what's happening at a depth just above the seal to the hydrocarbon, and start to fit a machine learning model to predict this, as a function of these 28 different variables. You take that data set to the side, fit a model, come back and predict the seal. Okay, so that's pretty sophisticated stuff, but we're able to do this kind of stuff because we've been doing this for a long time. I mean, these are much more sophisticated methods these days, but way back here in the New York Times, I did save this clip from 2017. I don't save a lot of stuff, but this is a New York Times article where Conoco was talking about billions of dollars in savings, using Spotfire. So this is one clip to make sure I saved. And I know Conoco, a lot of people I've met in Calgary originally were working for Conoco. So I know that there's a lot of history there. And then this completions accelerator. So if you want to look at your completions data as you're completing a well, look at the overall summary of a certain location, look at, filter that by well or stage or day, look at the KPIs that you're achieving in terms of proppant usage, slurry results and so on. That gives you a live view of that. From the well pad, you can look at the live streaming data coming off. This is used by Liberty Oilfield Services. Has put a lot of input into this accelerator. They acquired the fracking business from Schlumberger a few years ago. But being able to look down at the wireline parameters, the operation of the completions process, look at a lot of different things here. Coil tubing, crew locations. So there's both real-time data here as well as these things typically get updated every hour or so, and the company doing the completions is able to get a update during the day and across the time of the completions operation. Okay, so production, asset valuation, production forecasting, surveillance. This is where we start doing decline curve analysis and looking at, we've got a number of methods in here for estimating EUR in these transient versus boundary dominated flow models. So some of these models have parameters in them that look at transient versus boundary dominated flow, the extent of the reservoir, how close you are to the edge of it and so on. Getting type curves and economic forecasts for different production wells, and being able to look at that on a map. So here I'm getting data off an electric submersible pump. I've got pressure and current. If pressure goes up too high and current starts to go low, you've got an imminent problem. So being able to track this and look at those data on a regular basis as a function of well location basically gives a list of priority repair type jobs and being able to look at those. So Oxy, for example, does a big deployment of this across more than 30,000 wells worldwide to different types, not just ESPs, but beam pumps and gas lift and all their different types of retrieval type technologies. And then predictive maintenance. So this is where you, rather than just looking at the current condition of the data, you can kind of set up the cost of a planned maintenance, cost of an unplanned failure, and trade off. So this total unplanned cost, if you leave your time in service too long, then you're increasing the probability of an unplanned event, which is usually very costly. But if you, this is time in service on the x-axis, if you do your maintenance too often, then your cost of maintenance is too high. So what's the trade-off between too frequent and not enough maintenance, and find what's the sweet spot for particular types of equipment? Then finally, HSE. I mentioned carbon alpha. We're doing a lot of work, for example, in carbon sequestration and storage. It's kind of amazing what Chevron did in the north of Western Australia with this Gorgon deposit. They had a requirement from the Australian government in order to develop this massive field that they did some injection of compressed carbon dioxide back into the rock as a way of addressing environmental concerns. And we're seeing more and more of this CCUS type use case. And so in the Gorgon, they have a plan to capture 3 megatons of CO2 and store it into deep formations below this island that they're going to inject for like 40 plus years. This is a Chevron project in a joint venture with Exxon and Shell, but massive deployment there and monitoring of the CCUS injection. And then other types of health and safety, so reporting total recordable injury frequencies and high potential incidents, analyzing different sites by asset, location. We have various models like YOLO models, Python models to recognize images of vehicles, or we do a lot of this in our mining customers as well. So making sure that on site we have as fewer people as possible and monitoring activities to avoid avoid accidents. The various analyses we've done in that area. Some of the mining companies are remote controlled vehicles that are operating the mining operation. Okay, so that's pretty much it. I'm going to wrap up with just a few links that you might want to be aware of. The community, various accelerators, and there's a community club for the energy sector. Lots of articles you can search up there. The Copilot, along with the connectors, data functions, mods. This is the exchange. community.spotfire.com/files is where you can go and get all of the downloads. Now these go through a pretty exhaustive testing process and legal process to put them up here. So very, very thoroughly vetted and legally approved things for you to download. And some of the new ones I mentioned today, these new mods, including all the including all the stuff that I showed today, well log, well bore, 3D, well spacing, all that kind of stuff. So data functions, mods, accelerators, and some of the new ones, as I mentioned, that I showed today. And alerting framework, that's one for you, Phil. We've got to talk about that offline, but that's a very popular way of getting alerts from a spot fire analysis. I encourage you to take a look at the quick tip videos. We just got 14.4 just came out, and we've got a lot of quick tips on how to use it. I'll cover some of that in the, at the end of the roadmap session, and then the monthly Dr. Spotfire meetings. We've also just re-established our education certification program. In fact, Cadeon is our leader in this in terms of providing education to our customers, but the ability to also get certified now is a big deal. That had a bit of a problem when we joined Cloud Software Group. It kind of all broke, and so now that's back, which is pretty exciting. And that's it. A little bit of whirlwind tour. I covered a lot of territory, I know, in a short amount of time, but there's a lot to update you on. And if there's any questions, maybe we can take some questions.